So that day we were discussing about lubrication system. Yeah, you have drawn these diagrams now. Yes. A fast recap, any one of the students who can just uh, describe about this figure that is in on your slide. Some people did not receive the Canvas invitation. One of the students have written in the chat box. Last class, I have told you send me the message on WhatsApp. So few students have sent to me and I have given them the invitation and they have accepted also. You can discuss with Rahul Gandhi, your CR. Still, if anybody is left, you can send me your email ID to my WhatsApp and I will send you the invitation. Yeah. So anyone in the class who is going to describe about this diagram, a fast recap. Yeah. Where is Umair? Umair is there in today's class? Anyone? Anyone in the class?
No, sir.
Yeah, someone has said something just now.
So Umair is not present in the class.
Okay, so this is 394. So 394, I think this is Faizan.
Yes, sir.
You describe about this pressure lubrication system. The picture you can see in the slide.
Yes, sir.
Okay, so describe everyone about this figure. This question is very important. State and explain the working of pressure lubrication system with a neat sketch for your examination. If you want to make it 5-star, you can 5-star it. State and explain the working principle of pressure lubrication system with the help of a neat sketch. So you have to draw the diagram that you have drawn in the last class. This is somewhat 3D representation of that same diagram. Here you can see at the bottom there is a oil pan, or you can say as sump, where the lubricating oil is there. Okay, the lubrication process starts from this, what you can say, it is a strainer which screen out the dust particles or the weird particles from the this lubricating oil present over here. Then you have a one pump which pressurize the lubricating oil to the oil galleries. These yellow color lines that you can see, they are oil galleries. So after pressurizing it, it is going to oil filter. If still you have any burnt soot particles or metallic weird debris, that will be filtered out over there. Then it will be sent to all the places wherever the lubrication is required with proper channel. That channel is called as oil galleries, you can see here. So here, this is your timing gears. It controls the motion of your camshaft, crankshaft, everything. And here you have the crankshaft. In the crankshaft, you can see through these oil galleries it is coming, and inside you have holes. That holes are supplying the lubricating oil to different connecting rod journal bearings. Okay, these are your connecting rods, and from there it is going to your piston part also, where some lubrication as well as cooling is required. So if you remember, the function of lubrication system is to provide lubrication as well as it acts as a coolant also to reduce the temperature of the combustion chamber. So you can see here it is going to your valve system also. These rods are your rocker arms that is controlling the timing of your valve timings. So this is all about, you have here one oil gauge also that is used for regulating the pressure of the oil lubrication system. So this is pressure lubrication system, very much important for your examination point of view. So we have gone for a fast recap, and I expect you people also to since we have discussed that diagram 2 to 3 times in the previous class, so you should be able to explain it. Now, dry sump lubrication system. Now, as we have seen in the first video today, one of your friend has shown us a video about some sports car, Formula One
Porsche
racing car.
91, Porsche
Porsche
911.
919. Okay, so that was a Formula One racing car. In racing cars, dry sump lubrication system is used. It was mentioned in that video, dry sump lubrication system. So what is the difference between this lubrication system and the one we have seen in the previous slide? So the only difference is that here we don't have a bigger oil sump. Here we have a very small space below the engine, and we don't store the lubricating oil below your engine. For that, we have a separate oil reservoir that is outside your engine cabinet. Okay, and whenever a small amount of oil is getting accumulated over here, it is brought to your oil reservoir through this scavenging oil pump. So you have to remember this keyword, scavenging oil pump, that is used to get the oil from the, what you will say, sump of the engine to the oil reservoir, and then it is sent to oil filter to filter out any wear debris or burnt carbon particle. These two keywords also you should keep in mind. Wear debris, because there are reciprocating components which are having contacting surfaces, so there must be some wear and tear of the component metallic surfaces. So those wear debris will come to your lubricating oil. Another thing is, due to the combustible gases, so the burnt carbon particles will be there, so that is filtered in your oil filter. Then after that, it is sent to your oil cooler to reduce the temperature of your lubricating oil. As I have told you, lubrication system is having two functions, primary functions. First, to provide lubrication for all the moving parts, and the second is to act as a coolant to reduce the temperature of the engine. So that's why here one oil cooler is provided to reduce the temperature of your lubricating oil. Then again, you have one main oil pump that is used to pressurize the lubricating oil so that it can be sent to different parts of your engine. And here you have a pressure regulator to regulate the pressure of the oil. And this is the cycle. This is the line diagram of your dry sump lubrication system. So till now we have seen three type of lubrication system. The first one, we have seen splash type of lubrication system, in which at the end of the connecting rod you have a scoop like thing, scoop, like your ice cream scoop. Okay, and it was, whenever it was coming to the downside, it is scooping and splashing the lubricating oils to all the internal components inside your engine, and it was providing you the lubrication that is obsolete and not used nowadays. Then we have seen pressurized lubrication system. Just now I have described about it. And the third one, we have seen dry sump lubrication system. In some engines, combination of that splash and pressurized lubrication system also works. So that's all about your lubrication system. Here, viscosity. Viscosity, already we have discussed about these things, can be considered as a resistance of the lubricating oil to flow. Viscosity index is a parameter. You can remember this. Viscosity index is a parameter. It gives the indication of the change of viscosity of oil with temperature. A high viscosity index means less change of oil viscosity with the temperature rise. Petrol lubricating oils generally have a viscosity index from 100 to 110, which may be increased to 120 or 130 by means of additive. So this high viscosity index means there will be less chances of the change in the oil viscosity with the rise in temperature. Okay, so three physical, it should be have a good physical stability, means it should be the engine lubricating oil should be stable at the lowest as well as at the highest temperature. So that term is called your physical stability. Chemical stability should not have a tendency to oxide formation by combining with some different molecules. and it should provide resistance to the corrosion, should not have a tendency to corrode with the pipeline, crankcase, or any other engine parts. This is about your lubrication system and viscosity. Now today we will see oil pumps. As we all know that in the previous lubrication system, we have seen at the bottom there was after strainer we have one oil pump. So oil pump is responsible for circulating oil throughout the entire lubrication system. So what are the different type of oil pumps used for lubrication? We have gear pump, rotor pump, plunger pump, and vane pump. Uh, do you have seen about these different type of pumps in some other subject like fluid mechanics or
Sir, I have seen gear drive pump, sir.
okay, you have seen geared pump. So I will show you that gear pump once again, not only to you, but to the whole class. So let's see what is this gear pump. I'll take you to a garage of this person, and he's trying to show at the bottom, from the bottom of the engine, about his pump, oil pump. So let's see it. Then I will ask you someone to explain about it.
Hi, my name is Charles Panner, and we're going to go over some points of this engine, mainly the
This is video is having audio. Everyone is able to hear it.
Sir.
Okay.
Yes, sir.
Oil pump and the oil cooler and how the oil pump works. So if we come down here, we start off, all those components start off inside of your oil pan.
Sir, but there is disturbance, sir. We can't understand what he's saying.
Actually, this is a garage, and whenever you go to any mechanical workshop or garage, there will be lot of background noise. Okay, so try to focus on his voice.
Audio.
No, sir. No, sir. Voice is coming first,
Audio is
and
not clear, sir.
Background echo sound is there due to that hall is very big, so echo sound is there. So whether that problem is there or some other problem you are facing.
Audio is very low, sir.
Audio is very low.
Yes, sir. It is low and it is coming somewhat disturbance. It is coming.
Yeah.
Sometimes it is paused.
Is that like that?
Video is lagging, sir.
Okay.
yes,
Okay.
sir. Audio is coming first, and video is lagging, sir.
Okay. Okay. So let me play it from the beginning once again. Okay, maybe in between I have switched it to full screen mode, so that is one of the reason. So let's play in the small screen mode only.
Hi, my name is Charles Panner, and we're going to go over some points of this engine, mainly the oil pump and the oil cooler and how the oil pump works. So if we come down here, we start off, all those components start off inside of your oil pan on either your heavy duty engines or your gasoline engines. They're all, everything starts down here. So you drop the pan's already dropped. You come inside, come on in. This right here is your oil pump and your oil pickup. Now that picks up oil out of the oil pan. So this is bigger, it's a big area. It picks oil out of this big area, pumps it into the pump. So you got your pickup into the pump, and then from the pump, it is distributed throughout your system. And your pumps ran from your camshaft, at least on this heavy-duty engine it is. So now we're going to take the pump off, talk about some of the components of it, and then we'll go from that to the oil cooler. Don't show it. Don't show take out the pump. All right, so what we have here is the oil pump and the pickup. Pull it out from underneath the engine. You saw it underneath. This is what it looks like on the bench. So this is a twin gear oil pump, which we'll take it apart and show you the difference here in a second. We've got our pickup on this side, which bolts to it. We've got our pressure relief valve. We've got the actual gears, and it comes up. We've got the gear that attaches to the camshaft. So the camshaft actually runs this pump. So we're taking it apart. I'm taking a lot of the bolts out, so we only have one bolt. Take this off. Come in. see the gears I'm talking about. So if you look, so this came off. You've got the two gears in here. Now, you would think that the oil is pushed through the gears to create pressure for the system. That's incorrect. The actual oil is pushed along the walls of the actual pump to create the pressure. So the gears move in that direction. As the oil comes out, it pushes out and pushes in to the inlet or the supply. So that's how that works. Now these gears, this is called a twin gear pump. All right. There are three different types: twin gear, a rotary gear or gerotor gear, and an external pump system, which is similar to this, that attaches to the outside of the bell housing on motors, so either on-side, flywheel, or crankshaft along those lines. So from the pump, the oil comes up into the engine and gets used inside the crankshaft, inside the pistons, inside up into your camshaft, into your injectors, and on this side, and this side is our oil cooler. So all of our oil needs to be cooled down so that it doesn't build too much pressure up inside the engine. This right here is our air cooler, our oil cooler. This is a centrifugal flux filter. As it spins, it just filters out all the impurities. This right here cools our oil so that our engine stays cool. So the operating temperatures don't get too high, it doesn't burn itself out. So that's the basic components of this lubrication system and this type of twin gear pump. And go ahead.
So that's all. He was trying to show you the component where that oil pump is placed in the real engine. In the previous diagram, we have seen in the schematic diagram where that pump is there. But here we have seen at the bottom, you have the oil pump. And he was showing that pickup actually that sucks the oil from your sump. And then he have shown the internal of that pump where two meshing gears are there and that are pressurizing the lubricating oil. And he was mentioning that it is not the meshing part where the oil is getting pressurized, but it is the periphery of the inside of your pump surface and your teeth. The gap between those two things we will see in that line diagram, then it will be more clear. So yes, now it is open to all. Anyone wants to say something about this video, what you have seen in it? Yes, Munib, you are there?
Yes, sir, I'm here.
So you want to say something about this video, about this oil pump, how it works? Okay, no issue. So you have to keep in your mind that four type of gear pumps are placed over here: gear pump, rotor pump, plunger pump, and vane pump. We will see all of them one by one. So let's start with the gear pump. I have shown you the actual where it is placed and how it works. Then the line diagram of this gear pump is like this. Yeah, at these locations, the gap between your teeth and the inner surface, from this area, the pressurized oil get passed from these locations and it moved to the outlet from this side. This is your inlet where low pressure fluid comes into, and then these two are the rotating gears. They are running with connected to the drive shaft. Okay, and from the another side you are getting the high pressure fluid. So the fluid is carried between the teeth and the case. Okay, this you have to keep in your mind. So it is your gear pump. Now we will I have one more video in which all the different type of pumps that we have seen there, that is elaborated. So let's focus on this.
Rotary pumps.
Now everyone is having his notebook and your pen to note down these important points. Okay. And now the sound was going good for this video.
Yes, sir.
Okay.
Rotary pumps. There are 4 types of rotary pumps: screw pump, gear pump, lobe pump, vane pump. In screw pumps, it is the intermeshing of the threads on the rotors and the close fit of the surrounding housing that creates one or more sets of moving seals in a series between the pump inlet and outlet. These sets of seals or locks, as they are sometimes referred to, act as a labyrinth and provide the screw pump with its positive pressure capability. The successive sets of seals form fully enclosed cavities that move continuously from inlet to outlet. These cavities trap liquid at the inlet and carry it along to the outlet, providing a smooth flow. The pump is so named because it has 2 gears that are side by side or external to each other. A drive gear that is driven by a motor rotates an idler gear in the opposite direction. When the gears rotate, the liquid, which is trapped in the gear teeth spaces between the housing bow and the outside of the gears, is transferred from the inlet side of the pump to the outlet side of the pump. The meshing of the gears on the discharge side of the pump forces the liquid out of the pump and into the discharge piping. The lobe pump receives its name from the rounded shape of the rotor radial surfaces that permits the rotors to be continuously in contact with each other as they rotate. Lobe pumps can be either single or multiple lobe pumps and carry fluid between their rotor lobes much in the same way as a gear pump does. Unlike gear pumps, however, neither the number of lobes nor their shape permits one rotor to drive the other, and so all true lobe pumps require timing gears. Vane pump includes a rotating cylinder containing equally spaced radial pistons arranged radially around the cylinder center line. A spring pushes the pistons against the inner surface of an encircling stationary ring mounted eccentric to the cylinder. The pistons draw in fluid during half a revolution and drive fluid out during the other half. The greater the ring eccentricity is, the longer the piston stroke and more fluid they transfer. Applications of rotary pumps are: gear pumps handle more viscous fluids. The sliding vane pump suits both viscous and non-viscous fluids. Sliding vane pumps cannot handle dirty or gritty liquids. Vane pumps are ideally suited for low viscosity, non-lubricating liquids. Sliding vane pumps are used for vacuum services. Lobe pumps are used for food and beverage processing. Lobe pumps can handle both low and high viscosity fluids.
So that's all about our pump. You have seen here four type of pumps. So now who is coming into the picture to describe what you have seen in this video? Yes. Any one function, working of any one pump. Who will tell me?
Sir, actually, I have one doubt, sir.
Yes.
I'm Rahul.
Yeah, I can identify your voice. Yes.
Sir, how rotor and sorry, um, how screw and gear pumps create vacuum, sir. I mean, suction part is very important for that, no, sir. It has
Yes.
little very small size of creation of vacuum.
Yes.
So how they absorb how they sucks the oil from the sump, sir.
Yes. So as you can see, you have two components. Messing gears are there. Okay. About the rotor component, if you will see in this figure, okay. Let's come to more clear picture. Yeah, here. Your question is, if I am correct, why this suction? How this suction is getting created? Is that
Exactly,
what
sir.
you are asking?
Exactly, sir.
Yes. So whenever these two rotors will start rotating, okay, and they are in rotating in opposite directions, so automatically here suction will be created.
Sir, what about
Automatic.
in screw gearing, sir? Like
Same. The difference between this gear type and that screw type is only thing that you can say that screw is the extruded part of this gear type of pump. Same mechanism is working here as well as there. Okay, the oil, whenever it starts rotating, a suction will be created at this location. Okay, and it will find the way in this direction, and it will go around the periphery, and finally it comes to your outlet side. There will be some oil on this area also that will be in turbulence. Okay, so mainly the pressurized oil path is this one. Due to the circular motion of two messing gears, or you can see your what was that rotor type of shaft was there, this suction will be created. Okay, Rahul.
yes, sir. Main doubt in screws type, sir. That's
Hmm.
these rotary and vane and this gear type will okay, sir. Will
Mhm.
work as suction, but mainly in screw not possible, no, sir. That's the problem.
Why it is not possible?
So, when we consider the gate drive here, the possibility is that some drag force will be applied by these gears so that the suction takes place now, sir.
Drag force, where that drag force will come?
While rotating, some amount will be dragging us.
Automatically what happens, see, now I'm telling you the mechanism. When it starts rotating, okay, actually it is initially filled with oil. Rahul,
Yes, sir.
it is filled with oil. So when it starts rotating, then what will happen, the oil present over on this side, okay, in this area, it will be pushed to move outside, whether it
Sir.
will happen or not.
Yes, sir.
So when this oil will move from this side, so what it will try to do, it will try to move its adjacent molecules. This molecule will try to pull this part, this molecule will try to this part. So what will happen automatically here, suction will be created at this location, because the oil on this side, it will be forced to move outside. Okay, so it will try to pull the adjacent oil molecules, and finally suction will be created on this side. Same is
Okay.
your with your what you have said. Which type of pump?
Screw
uh, One type
screw
of pump,
pump.
screw pump, that
Yes,
is
sir.
actually used for more slurry kind of things to be handled. You know what is slurry?
More slippery.
Low viscous.
Very high viscosity, like how I would explain you, in oil refineries. Okay, you have studied about the fractional distillation tower. Have you studied or somewhere heard about this fractional distillation tower? How these petroleum products you are getting from the crude oil, okay, like diesel you are getting, petrol you are getting, mobile you are getting, other lubricating oils, and finally some jelly substances at the bottom. So have you heard of this fractional distillation tower?
No, sir.
Yes, Rahul?
No, sir.
You might have studied in your basic sciences during your school days. Okay, so this crude oil, how from the crude oil you are getting petrol or diesel or your mobile or your lubricating oil, everything is coming from that crude oil. Not only these oils, even your petroleum products like Vaseline you have seen, or any jelly substances, they are the byproduct obtained from your fractional distillation tower. So once in a year or 6 months, that fractional distillation tower is cleaned. Okay. So what happens? Lot of residue material is collected in the form of solid. Solid means semi-viscous. Okay. So those things are like then converted into muddy substances. Okay. And that mud is handled, that kind of muddy substances or slurry substances is handled using your screw pump. Their discharge rate is very slow, very slow, 5 liter per hour or 10 liter per hour. Okay, I have seen that pump, that size of the pump is very big. I have worked with in one project with HPCL, Hindustan Petroleum Corporation Limited. So I have worked with their R&D team. So we were trying to add the hydrogen sulfonation, actually we were doing with that residue of your uh, fractional residual substances, actually that are called as petroleum companies waste. So we were trying to convert that again into the diesel or other petroleum substances. So in that I have seen that screw pump is used to move that slurry substances at a very small flow rate, but that system is very highly pressurized. 100 bars of pressure is there in that system to move that slurry substance. Okay, so that is now patented with HPCL and CFRI. So with the addition of hydrogen from water, that muddy substance residual petroleum can be again converted into diesel or petrol. So this is about your uh, gear pump, and some discussion from your friend about other type of pumps. Now one by one we will see the diagram of all the pumps, and you have to draw it. You have to draw it, then only you will get practice. And I want to see what you are drawing in your canvas. So not today, the time is almost over. Okay, we will discuss these diagrams and the function of all the different type of pumps. I have those diagrams. We will discuss its working, its function, and you people will draw the diagram of it. So that's all for today's class.
Sir, a small doubt, sir.
Yes.
What is the minimum pressure for oil to be pumped, sir? And what happens if it is pumped at high speed and low speed?
What is the minimum pressure requirement for oil to be pumped?
Yes,
This is
sir.
your question?
Yes, sir. And what are the variances in low speed and high speed?
For the first part of your question, I would tell you that there is no any requirement. Only requirement is not on the inlet side. Requirement is there on the outlet side. Suppose I want to lubricate all the contacting parts of your engine. Okay. So to reach all the areas, we are actually flushing through small nozzles. So to reach all the areas from the nozzle tip, how much minimum pressure is required? That is the requirement, and that is on the outlet side. For inlet side, there is no requirement as per my opinion or my knowledge. Okay. So that minimum outlet pressure should be fixed, that when we are sending this high pressurized oil, it should be high enough to reach all the components or all the parts wherever lubrication is required. And still there is one more condition: it should not be higher than the set value, or it should not be much higher that your any tube will rupture from somewhere. So there At the outlet side, pressure relieving valve are installed. Pressure relieving valve. If it goes beyond this much pressure, it will release and the oil will again come back from the cycle to your inlet side or your oil sump. Okay.
Okay, sir.
So who asked this question? This was a very good question. Your
Umair, sir.
name? Umair. Okay, very good question.
Thank you.
So if you have any information about the value of that pressure, you can share with the class, with me. Do
Okay.
you have any idea?
Currently, I don't have any such particular.
So this you can take as an assignment to all the students. Like you have selected some engines, so you can search for any engine. Suppose your bike or your scooty or your car, that I have this engine, and for lubrication this much pressure is required for my vehicle, and this is the engine oil or lubricating oil. What is the name of that oil that is used? So this much is this is your assignment. So all of you can write in your notebook, and then we will discuss in the next class. So it will augment the knowledge domain for everyone, which vehicle is using how much pressure of oil, and at the same time which oil they are preferring. Okay. Okay, students.
Yes, sir.